Hey there, welcome to dotnetFlix. And hello to you, Edwin.
Hey, Sander, how you doing?
Yeah, I'm doing great, thanks.
Awesome.
So today we're going to talk about Dapr, and Dapr is abbreviation of the Distributed Application Runtime. And
Mhm.
we talked a couple of times, I think, about Dapr on the past on dotnetFlix. And the way I like to think of Dapr is that it's this really useful toolbox which contains a lot of building blocks that allows you to really easily build your microservice or distributed applications, right? So there's a lot of good stuff in there.
Yep.
Um, but today specifically, we're going to talk about, well, actually, you are going to talk about this new addition, right? Called Workflow.
Yeah, Dapr Workflow. That's actually a new building block. So, like you said, we talked about these building blocks a lot, and there's things like pops up and everything. And we will have some link in the show notes to get you to the documentation and to
Mhm.
a Dapr book that we wrote. So, yeah, there's lots of information out there. I also assume that you know a little bit about what Dapr is if you're watching this session. If not, then you can follow the links for more information. But yes, there's a new kid in town if we look at the building blocks in Dapr, and that is the workflow building block. And it is actually still in alpha, so it's still being developed,
All right,
and there are
early
some rough
days.
edges. Yeah, it's early days, and there are some rough edges, so fair warning up front. But I'm going to show you what Dapr Workflow is, how it works under the covers, and also do a demo of a workflow that I've created in C# with .NET to show you how this works. So yeah,
Awesome.
excited to talk
I,
about
I
this new
haven't
building block.
looked at the building block at all up until now, so I'm really curious. So yeah, let's dive in.
Yes, I will dive into the slides. So first of all, this is the collection of building blocks that you see here, and I've highlighted the workflow building block. So that's what we're going to talk about today. So let's look at the slides. What is Dapr Workflow? Actually, Dapr Workflow is a building block for building process logic and process logic in the broadest sense of the word. So I've added sagas here because that's a term that you often hear when we talk about processes in software. And it's basically about orchestrating microservices or other components in a reliable way. And this can be very hard because you have to do all kinds of things like maybe compensation if something goes wrong, or you have to, do some parallel stuff. And we all know that building that kind of software is pretty hard to do. Um, like I said, if you know how Dapr works, so there's the whole sidecar thing, which offers you an API, an HTTP or gRPC API for doing all kinds of stuff. Well, this is again the same thing. So you have an API that you can call on your Dapr sidecar for interacting with your workflow. And as I said in the introduction, it is still in the alpha stage. It is being developed. So make sure that you don't run production as of yet. But yeah, make sure that you know what the issues still are. And you can find these on GitHub, right? This is all open source, so you can see all the issues that are out there, and you can even contribute if you want. So like I said, the really cool thing is that because you're running in a Dapr sidecar, you can use all the other Dapr building blocks. So, for instance, reacting to a message coming in through a message broker using the pub sub building block, and then triggering something in your workflow is really easy to do because it's all Dapr. You can just combine all these building blocks together. Another important thing to note is that under the covers, the whole workflow building block is implemented using actors, using the Dapr actor model. If you don't know what the Dapr actor building block is, then look at the documentation because it's really good to know how that works under the covers to understand exactly how Dapr Workflow works. And if we then look at the features that Dapr Workflow offers, then of course there are workflows and activities. And workflows are a collection of activities that need to be executed, obviously with some process logic in between. You can actually call child workflows to do some sub-process like processing. You can do durable timers and reminders, just as the actor model provides you. So you can just wait on a certain action or set a certain timeout on an action that needs to wait for a certain time. You can use those as well. Then there are a couple of workflow-specific retry policies. So obviously in Dapr, there are several places that you have retry mechanisms already built in, but these are additionally added to the workflow building block. They are specific for workflows. I'm not going to go into that in this session because there's lots of stuff actually that I don't cover in this session because there's lots of documentation out there. But yeah, make sure to read the documentation and then you can use all these features. What's also a very powerful feature is that you can wait for external events, like I just said. So maybe I'll trigger some a child process and then some other system has to do something. And once that system is done, it can send back an event and then trigger the workflow again. And that will start where it left off last time. So that's pretty powerful. Also for instance, manual interaction by a human, that is a really cool pattern to use. And then finally, there's open telemetry distributed tracing built in. So you can also follow along what's happening in your workflow, which is very important, obviously. So those are the features. And these are a couple of examples of patterns that you can use or that you can implement using workflow. So one of the more simpler one is task chaining, which is basically a set of activities that have to execute after another, and maybe also output from one activity needs to be used as input for the next activity, and this way you can chain together a couple of tasks. And of course, this seems very simple, but what needs to happen when, for instance, in this example, activity 2 fails and you have to do some compensation or you have to retry stuff? And with Dapr Workflow, there are patterns available to implement this. There's also an SDK available, I will get into that a little bit later, that you can use to build all these logic. Another pattern that we often see is the asynchronous API. Like you set off some operation that is long running, and then you can poll for the results. Then there's fan out, fan in. So maybe you want to set off a couple of workers that have to do some work, and you have to aggregate the results of all these workers. Well, that's a pattern that you can easily implement using workflow. Another one is monitor. Well, I won't go into all of them. And then the last one, manual tasks, which I already touched upon, is really important if you have, for instance, a real business model workflow or business workflow that has human interaction. And we will see a sample later on in the demo. So let's look at what's going on under the cover. So what actually happens when you use the Dapr Workflow building block is that the workflow engine actually runs inside the Dapr sidecar. But actually, you write the workflow and the activities that need to be executed in your application. So that's part of your application. And the only thing that the Dapr Workflow engine does is scheduling these activities and these workflows. And this all happens over a gRPC channel that's opened once the application is started. And then you can start executing the workflow. So this is how that works in detail. So when you build an application yourself and you want to use workflow, when you start up, you connect to the workflow runtime that's running in the Dapr sidecar over a gRPC streaming connection. And then it will register the workflow and all the workflow activities that are available in the application with the workflow engine. And then once this is all set up, then the workflow engine will start scheduling these activities, doing all kinds of stuff like state management, retries, and all that stuff. That's the responsibility of the engine. So actually, your application will pull work items, let's call them work items, so stuff to do. It will pull them from the engine, and then it will execute the code that you wrote, like the activities or the workflow. And because this is a pull model, that means that your application doesn't need to open any ports or has to listen on anything. So the Dapr sidecar will never communicate with your application code for workflow activities, at least, but your application will pull the activities from the workflow engine. Then let's look at how the actual workflow engine executes these activities. Well, you see here a schedule of an execution of a certain activity, let's say. But before it does that, it will create a reminder. And this reminder is really important because once the workflow actor will call the workflow code that you see on the right, and something goes wrong, then once the reminder fires, it will just retry again to execute this step. Once the step has been executed successfully, then the reminder will be deleted. So you can see here that it is actually using actor reminders for creating resiliency, because if something goes wrong in your application code, maybe a service that you're calling is offline, or you just get an exception or whatever, then the workflow will not be broken and it will just resume where it left off the last time you executed. So this is pretty powerful stuff that you don't have to build anymore. And then finally, like I said, we need to have stateful workflows, because when we restart a workflow, or we continue a workflow where we left off, of course, we need to have all the state that we aggregated up until that point. So for that, there's already an event-sourced way of saving the state of an actor. So actually, by using actors for implementing this whole workflow thing, there's already state management in there, because every time an actor is triggered, so started or restarted, it will just reload the history from the state store, and then your complete state will be rebuilt. Okay, so I think that's enough slides for now, and let's dive into the demo to show you how you can actually use the Dapr Workflow building block for actually implementing workflows. So for that, we're going to go to the Camunda modeler. I use the Camunda modeler a lot for drawing these BPMN diagrams. And this is basically a simple loan application process. And we will go over the steps, and then we will go through the code of this workflow using Dapr Workflow. So make sort of a mental note of this process. I will go back to it during the demo a couple of times to make sure that we're all on the same page. But for now, let's dive into Visual Studio Code and show you the solution that I've created for this demo. So first of all, there are two services in this solution. One is the customer service. And well, this customer service is actually just a mock service that is just an ASP.NET Core application, a web API. And I can give it the name of a customer, and it will give me some mock data of this customer. I won't even look at the code, because it's just plain old C# ASP.NET Core web API. So what I'm going to do is I'm going to start this service with Dapr, and for that I'm going to use this command, and I don't want to type a lot, so I just created a PowerShell script for this. I use the Dapr CLI. I give the command Dapr run. Then I provide it with a unique app ID, and we will use this app ID later on in the demo, which is customer service. I specify the Dapr HTTP port, which in this case is 3600. My application, so my ASP.NET Core Web API, is running on port 5070, and then I start the service by doing .NET Run. So let's do that right now. So I will open up a terminal window here. I will go into the customer service folder, and I'm going to call that PowerShell script to start it. And then we will see some Dapr logging, and then some application login, and then everything will be up and running. So here we go. Now everything is running. And to give you a little idea of what this service does, I have created some HTTP requests using the REST client, or the REST client tool. And what I can do, this is where the service is running, localhost 5070 /customer/ and then the name of a customer, in this case, Mr. Eric White. And when I send the request, I actually see it coming in and being handled here in the logging. Then you can see that I get a 200 OK, and I will get some information. And in this case, it's the unique ID of the customer. It's the name of the customer. The outstanding amount in loans, in this case, it's 12,500, and whether or not this customer has defaulted in the past. And in this case, the customer hasn't. So this is the information that we can work with during the demo. So that's the customer service. Now we will go into a more interesting part of the demo, obviously, because this is the loan application service, and this is also where the workflow lives. And in this case, this service is also an ASP.NET Core Web API that contains the workflow, but this is not necessary, right? You can basically use any kind of .NET tool. You can use a console application, a container. It doesn't matter. You can host this in any .NET process, or any other process for that matter. You could also do it in Python or whatever. But in this case, it's .NET. So first of all, let's look at the controller. The controller is, in this case, the loan application controller, which is just an ASP.NET Core Web API controller. But then we already see some workflow, Dapr Workflow specific stuff popping up. So first of all, what we can see is through dependency injection here in the constructor, the Dapr Workflow client is injected. And the Dapr Workflow client is a class that comes from the Dapr Workflow package that I've included here. It's just a NuGet package, and that's basically the Workflow SDK. And this workflow client can be used to interact with workflows. You can start workflows, you can stop them, you can purge them, you can send events, well, all kinds of stuff for interacting with the workflow. Well, this gets injected into the constructor, and I will save that. And then if we look at this operation, the start loan application operation. This is basically just an API call that I can do. I pass in a loan application of I pass in a loan application payload, and this is just a simple DTO, data transfer object. So it's just, in this case, it's a record. It has 3 fields: the applicant name, the loan amount, and the yearly gross salary of the applicant. So pretty simple stuff. And then what happens here is pretty straightforward. I create a unique ID based on a timestamp. This will also be my workflow ID. So that's pretty important that you have unique IDs for all the workflow instances. And then using this workflow client, I schedule a new workflow. And I pass in a couple of things. First of all, I have to specify the name of the workflow. And in this case, I use the loan application workflow class, which we'll look at in a moment. And I take its name. I pass in this unique instance ID that I can use to reference the specific workflow instance. And then we pass in the input into the workflow. In this case, the loan application information. And then what I send back is a loan application started. And this is also, again, a very pretty simple plain old C# object that only contains the instance ID. And this is the instance ID that the outside world calling this API can reference the workflow instance with. So pretty straightforward stuff. It's not real complicated. And of course, this SDK does a lot of heavy lifting for you. So it is also advised to use the SDK as much as you can when working with workflows. But as we will see later on, we can also just use the Dapr sidecar directly. So now let's look at how is this all working, because where does this Dapr workflow client comes from, and this loan application workflow and all the activities we'll look at in a moment. How are these registered? Well, obviously, this is an ASP.NET Core web application, so this is done in the program CS. You see some stuff that you should recognize if you worked with web APIs before. And here, where all the services are registered, you see some Dapr workflow specific stuff. So it says add Dapr workflow, and then here, using the options, we register the workflow, and we register all the activities that are part of this workflow. And by doing this, we actually register the workflow and the activities. And then, as you recall, there will be a connection will be made between this application and the Dapr sidecar. There will be a gRPC streaming connection. And once the workflow and the activities are registered and everything is set up, then you can actually start instances of this workflow. So that's how that works. And we will see that in a moment in the logging when we start the workflow. So now, without further ado, this is all stuff around our workflow. And now we're going to look at the actual workflow. And this is in the workflows folder. And I have the loan application workflow, and I have an activities folders with all the activities we will look at throughout the demo. So let's open this workflow and scroll to the top. Sorry for the scrolling. And we'll go through this workflow, and then I will reference the process that I showed you before to show you where we're at in the workflow. So first of all, this loan application workflow derives from workflow, which is a class from the Dapr Workflow SDK. You have to specify what is the input. And again, we see the same loan application type here. And we have an application result, which again is a very simple DTO that only provides us with information whether or not the whole loan was approved or not. But this could be anything that you need for your scenario. In order to be executable, we have to override a certain operation, and in this case is the run async method. And this run async method, you have to specify what the result is. Well, in this case, it's the application result. And then there are a couple of things passed in. First of all, we get the workflow context. This is something from the SDK. And this workflow context gives us all kinds of interactions with the workflow. So it has all kinds of properties, whether or not I'm replaying, the instance ID, the name of the workflow, well, et cetera, et cetera. And it also has a lot of methods for interacting with the workflow, which we'll see later on. And we also get the input, in this case, the loan application. And once we start an instance of this workflow from the API, then this will start executing. So what will happen is, if we quickly circle back to the process, the first things that we were going to do is determine whether this is an existing customer, and if not, we'll register the customer. So let's look at that code in the workflow. So the first thing that happens here is that I am calling an activity, and that's basically what you do all the time. These activities are your building blocks, and you're actually building a workflow using these separate building blocks. And as you can see, I can use this context, the workflow context that was passed in, to call an activity. And then I have to specify what is the output of the activity. In this case, it's customer info. And if we look at the customer info, you will recognize what we just got back from our mock service, the customer service. It is customer info with an ID, a name, an outstanding amount, and whether or not the customer has defaulted. All right, so pretty simple stuff. When I call this activity, I have to specify the name of the activity, and I'm using the name of here, and I use the determine existing customer activity class, and I have to pass in the input. And in this case, it's just a string. It's only the applicant name that I have to provide to this activity. So let's look at this activity. It's basically just a C# class, which derives from workflow activity, again, from the Dapr Workflow SDK. The input is a string, the applicant name in this case, and I will return a customer info. And in this case, it's nillable customer info because I've chosen here to implement a customer that is not found, so it's not an existing customer, just to return nil, so the workflow can handle that. But you can do it differently, but in this case, this is fine. Then we have a constructor, and as you can see here, a logger factory is injected, and you can also inject multiple things here. So everything you need within your activity to actually do the logic that you need to do, you can inject here. So for instance, if we look at the run async method that we have to override in order to be executable, I'm actually creating a Dapr client here using the Dapr client builder, but I could also have chosen to inject it here using dependency injection, but that's up to you. So the run async is something that we have to implement. Again, here you can see a task of customer info or nillable customer info as a return type. The workflow activity context is inserted here. This is not the workflow context, but the activity context. And the activity context doesn't have a lot of stuff up in there. It just has the name and the instance ID of the workflow instance that I'm a part of. And this is the name of the activity. So no methods here whatsoever. And then, of course, we get the input for the activity, which in this case is the applicant name. So I'm creating a Dapr client here, and I'm going to invoke the customer service using the Dapr invoke building block, so the service invocation building block. So I'm creating a request here. I want to do an HTTP GET on the customer service. This is the application ID that I've provided to the application or to the customer service earlier. And then I'm going to call the /customer/applicant name URL. And this will send back the mock data that we saw before. And then we will invoke this and we will pick up the response. Well, if we don't find the customer, we will just log that to say, okay, we didn't find any existing customer and we just return nil. And if we do find the customer, then we deserialize the customer info information into a customer info object, and then we will return that to the workflow. So pretty straightforward. I'm just building C# code here. I'm doing a service invocation. I could also have done stuff with, sending a message to a message broker or put something in state store or whatever I want to do. That's up to me. So once this has executed, I can determine whether or not the applicant is an existing customer by checking for nil. And then I have an existing customer property or variable in this case. And this is pretty important to notice that I can just create local variables here within the scope of this method. And these will automatically be part of the state of the workflow. So I don't have to store that anywhere in an external state. That's exactly what the workflow does for me. So every time this workflow has to wait on some external event or wait for an async method to complete, the state is being stored and the workflow will take care of that. You don't have to do anything. You can just create local variables. So then we come to the next part. So as we saw in the process, if this is not an existing customer, so if not an existing customer, then we call an activity async. So we call another activity, in this case, the register customer activity. I won't even look at this activity because it doesn't do anything. It just logs that it created a customer. But this is all about the workflow stuff, obviously. So not about the implementation of the activities itself. So bear with me on that. Okay, so if we quickly circle back to the process, once we have the customer registered or we have an existing customer, it's now time to determine the risk profile for this loan. So what does this look like in code? Well, first of all, we're going to collect some data that we aggregated over the course of this workflow. So we're creating a new application info object, and we put in the loan amount from the application and the yearly gross salary of the applicant. We also pass in whether or not it's an existing customer, and then we also pass in the outstanding amount and whether or not the customer has defaulted. And then we call the determine risk profile activity, and this determine risk profile activity will just take this information and determine the risk class and an additional risk clause, an additional clause that we will have on the policy. So if we go to this risk profile, which is the output of the activity, it has a risk class and it has risk clauses, and it has some print functionality to make it easy to log this to the console. So pretty straightforward stuff. And again, I just call this activity. I pass in the application info that I've just created here, and then a risk class will be created, or a risk profile will be created. And that's basically, it becomes a bit boring after a while. You just call all kinds of activities, and these activities are implemented as workflow activities. So let's go on to some more interesting stuff. So if we go back again to the process, once we have determined this risk profile, we kind of check whether or not the risk class is 3 or higher. And if that's the case, we need to assess the application. So what does this look like in the workflow code? So the first path that we see here is the path when the risk class is below 3. And then you see that the loan is automatically approved. And then the workflow will just continue. In case there's a risk class of 3 or higher, we will go into this path, and then something new happens here. So here we will wait for an external event, and this is a new method that I'm calling on the workflow context. And what I do is I specify the payload that I expect when this event is raised, and this loan assessment completed event has only one field. It just has a field whether or not the assessment is approved, or the loan is approved or not. And then I have to specify the name of the event. And in this case, it is loan assessment completed. So this is a pretty straightforward method. I wait for an external event. And basically what happens here, once this executes, the workflow will become dormant. It will just wait for this event. It can actually be unloaded from memory because, yeah, as we saw before, it has state management. It is all stateful, so nothing happens. And once this event comes in, everything is reinstated, and the workflow instance will just continue here. And then the next line in the workflow will be executed, which is this one. So we will determine whether the loan was approved or not. So what I want to do now actually is just start the workflow and see this in action. So I'm going to create a new workflow, and then we will see, based on the log events that are being written to the console, we see what's going on. So first of all, what I need to do is I'm going to create another terminal window, and I'm going to go into the loan application service. Oh, wow. See, that's why I don't type. And I'm also going to start this service with the Dapr sidecar. It's running on a different port, obviously, because this is all in self-hosted mode. It's not running in Kubernetes or whatever. So I have to make sure that I don't have any port clashes. And then we have to look at the logging for some time because the application has started. And now you see this message coming up. So the sidecar work item streaming connection has been established. And this means that the workflow is registered. All the activities are registered. There is now a connection, a gRPC streaming connection between my application and the Dapr sidecar. So what we're now going to do is I also created an HTTP test file for this scenario. And here you can see a request that is calling my ASP.NET Core Web API, the loan application operation in this case. I pass in the application info, as we saw before, the applicant name, the loan amount, and the yearly gross salary. And this will actually kick off a new workflow. So let's execute this request and see what happens. And you see already some stuff coming here in the log window. Well, first of all, let's see what came back from the API call. Well, I got a 200 OK, so everything went well. And as we saw before, this instance ID, the unique instance ID of the workflow, is returned, so I can use that to reference that later on. And now let's turn our attention to the logging, because a lot of stuff is going on here. So what you see first is that there's a log line that says that a new loan application workflow orchestration with this unique instance ID was started. So this is the indication that the actual workflow instance has been created and it's executing. And then we see a couple of activities being executed. So first of all, that's the determine existing customer activity. And it tells me that the customer service was called and that the customer was actually found. So this is this Mr. Eric White, as we used in the payload, is actually being found by the customer service. So we have some existing customer information. Then we determine the risk profile. So this activity is executed. And we see that the risk profile that was determined comes at class 3 with a risk clause A attached to it. So that's fine. And then if you recall from the process, if the risk profile has a class of 3 or higher, we actually need to assess the workflow. And that's why I'm now waiting for this loan assessment completed external event. So we're actually in the workflow. We are now waiting for this event. So we're actually waiting for this to finish. I could now use the SDK. So I could use the Dapr Workflow SDK to actually interact with the workflow and raise this external event. But I want to do something different. And I want to show you how you can actually just call the Dapr sidecar and then use the Dapr Workflow API to actually raise this event. So I'm going to go back to my test HTTP file. And one thing that I can do here is I've named this request. So this is start loan application, and I've just executed it. And what I can do now is I can use this syntax. And this is, again, this is the REST client tool. This is a plugin for Visual Studio Code, a really cool thing. And I can reference the instance ID that came back in the body of this former request, the start loan application request. And then this will be populated with the instance ID. And you already see in my IntelliSense that it has the ID as the value. And then I'm using that in the URL here. So if I hover over this, I can actually see that it is filled with that instance ID, which corresponds to the instance ID of the workflow. So now let's look at the request I'm going to do. I'm going to do a post on HTTP localhost 3500. This is where my Dapr sidecar is running. I'm using the V1 Alpha 1 API. I'm using the Workflows API, or the building blocks, so to speak. I'm using the Dapr workflow component, and this is something that's interesting because this means that you could also use different workflow engines with the workflows building block. We're not going to go into that during this session, but in the documentation there's information on that. Then we have to specify the instance ID we've already mentioned. And then we're going to say we want to raise an event. So this is the interaction I want to have with the workflow. I want to raise an external event. And this is the name of this event, loan assessment completed. And that's exactly what we are waiting on, obviously, now within our workflow. And then we can specify a payload. And in this case, as we saw before, the data transfer object only has an approved field. And in this case, we're going to approve the loan. So we're going to say true. So now I'm going to invoke this request. You see already some logging coming in, and you see here that I get an HTTP 202 accepted. So that seems like everything works out. And then if we turn our attention to the logging, this was the last logging statement that we had. We were waiting for this external event. And now you can see in the log that the loan assessment completed event was raised on the workflow with that ID. And then you see that the workflow has continued. So it tells me that the loan was approved, and that's correct because we said approved is true. And then the next activity was executed, the loan proposal was sent. So if we circle back quickly to the process, this has happened now. We have said, okay, the loan has been approved, and now we have sent the proposal to the customer, and now we're waiting for the customer to send back a decision. And this is where this 14-day timeout is set to. Obviously, we don't have 14 days to wait during this demo. So in a moment, we're going to fix that. And I'm going to show you what happens when the timeout expires. But for this workflow, for this demo, I will raise this event that we are now waiting on, and which is in this case, the customer proposal decision received. And if I show you in the code what happens here, so this was executed, the loan assessment was approved. And Then I'm going to say, if it was not approved, we would send a rejection letter, but that's not the case. It was approved. And now I'm going to send the proposal that's already been executed. And then I'm going to wait for an external event again. And here, this is the implementation of this external event. It is the customer proposal decision received event. It has a customer proposal decision received DTO that I expect in the payload. And again, this is very simple DTO that only has an accepted field in there. And what's different to this one from the former time we waited for an external event is that now we have specified this 14 days time span that we want to wait. And then after this time span expired, something happens. We will get into that a little bit later. But for now, we're going to trigger this by sending it, by raising the external event. So again, we're going to use the Dapr sidecar. I'm going to send the request, and then the decision will be sent to the workflow. Again, 202 accepted indicates that it was successful. And if we now examine the logging, we can see that the customer proposal decision received was raised on the workflow. The proposal was accepted, the contract was registered, the contract information was sent to the customer, and the actual loan application workflow instance completed, and we're done. So this is an entire workflow that ran to completion. Pretty cool stuff. So there's one thing I still want to show you, and that is this timeout mechanism, how that works. So what I'm going to do now is I'm going to stop this. I'm going to stop the service. And I'm going to change some code here because I want to show you what happens. So I'm going to change this 14-day timeout to 20 seconds. From seconds. So this is obviously not a production scenario. By the way, all the code that I'm showing you is obviously not production code, but the same goes, for instance, for this workflow. I've chosen to put all the code just in one method. So it's a very long method with all the workflow statements in there. You could also create nice methods or whatever you want to do. It's just writing C# code, right? So that's up to you. But for this demo, it was pretty easy to put it all into one method. So I've changed this. And now we have to look at what happens when this timeout occurs. Well, once you start waiting for this external event and you've specified a time span and the time span expires, then a task canceled exception will be thrown. And you can use this mechanism to handle this timeout. So actually, this is going to be skipped. This is going to be, basically interrupted. And then this flow will start. And in this case, I'm not doing much. I'm just telling that the customer decision was not received within the timeout. And then based on that event or on that Boolean, I will say, okay, we have to contact the customer now. We go back to the process. If this fires, then we'll go into this alternative flow, and we have to contact the customer. And that is implemented again using an external event. And in this case, we're waiting for the customer contacted for proposal events. So let's run the service again and then do the same scenario to show you what happens when this timeout occurs. So we have to wait for everything to set up, for everything to register, and for the streaming connection to be made between the application and the workflow engine. There we go. Everything is set up. And now I'm going to start a new instance of the workflow. And I'm going to, I'm just going to change this to 50,000. It doesn't really matter, but for the demo, and I'm going to send it. And now we can see that the workflow is executing again. And now, because we lowered the loan amount to 50,000, you also can see that now the risk class has become 2, and we don't need to assess the loan anymore. So the loan is automatically approved by the workflow. And then the workflow continued. And now you see what happened here. So we were waiting for an external event, customer proposal decision received. And then after 20 seconds, the timeout occurred. The workflow went on. And now we are waiting for customer contacted for proposal external event. And now we can also trigger that because I also have a request set up for it. So in this case, the customer contracted for proposal external event. And in this case, we're going to, not accept the proposal. I'm going to send a request. And now you can see that the customer contacted for proposal event was raised, and then the loan proposal was declined, and then immediately the workflow completed, because if you go back to the process, we were at this junction, and we said, if the proposal is not accepted, then the workflow will just end silently because no other activities will be executed. So that's exactly what we wanted. Yeah, so that's basically what I wanted to show you when it comes to workflows. It's all about scheduling activities. Within these activities, you actually do the work you want to do, the business logic, and these are basically your building blocks. So yeah, that's it. That's what I wanted to show you, Sandra.
Yeah, so thank you very much for that cool demo. It looks really nice and flexible. It reminds me a bit of systems like Temporal IO, which also, put the workflow outside of your application and then call back in. I also think it's really interesting that we start to see Dapr's building these more higher level building blocks that use the more fundamental building blocks to basically to build further stuff on.
Yeah.
I guess that's something that you also have to keep in mind when looking at these preview states, because workflow is still in alpha, right? So that's really early days, but it uses a underlying state store component because it builds on the actors. So even when workflow is going to be G8, then you still need to take care that you also choose a storage component, a state store component that's also G8 if you go into production, right?
Yeah.
So there are various levels of preview states.
Yeah. And I haven't looked into if you can change out the state store, if you can do that yourself, or is that whether that is something that's internal to Dapr Workflow. But I think that it will be a probability, because you also have the if you remember these URLs, these have Dapr in the name.
Right.
That's the component. So you can also swap it out for a different workflow engine or a different state, I guess. But I haven't looked into that. But that's probably something that you can do.
Yeah, so the way Actors building block does this is it just goes with whatever state store you've configured to enable Actors on, and I guess Workflow will use the same one.
It will probably use that, but I'm not sure, so I'm not able to tell you whether or not that's the case, but it probably will be. So that's something that I have to still look into. So like I said, it's pretty new. I've just started looking at it, but I must say that the documentation is very elaborate. So we'll send also a link. There's a good sample. So yeah, it's a really good one to watch out for, and I'm really curious to see when it GAs, because I actually need this in a couple of projects.
You need this now.
So I need this now, but it must be stable and stuff. But yeah, I think it's pretty cool and pretty promising.
Have you found any limitations we need to be aware of? Like I noticed that you're putting in these long reminders, days. I guess that's not a problem, right? Because this is made for long running processes.
Exactly.
But should you, for example, take care of not using too many activities in your workflow and stuff like that?
Yeah, that's something that you need to do, because reminders are also, if you have a lot of reminders, this can have a performance penalty, right? So it is always, you have to look into that. Also, obviously, the longer your workflow runs, the higher the risk that you need to change something in the workflow. And what are you going to do with existing instances and stuff like that? So that is something that you always have to take into account with every workflow engine that you use. But yeah, of course, this is then, if you compare it to, for instance, a Camunda or some other workflow engine, this is a little bit more low level than that. So you have to take into consideration that that your code still runs when you change something in the workflow. That's something that you really need to take into consideration. Whether or not that is something that is specific for this workflow engine, I think not, because every workflow engine has this problem. So you always have to be careful with these long running stuff.
Right.
Yeah.
It's still good advice to take into account, right?
Yeah.
Well, thank you so much. I am also very curious when we are going to see a GA and how it all turns out. I really like what I'm seeing here. So thanks so much, Edwin. For those watching, thank you so much for watching. Please subscribe if you like the episode. It really helps the channel, and we'll see you next time. Bye-bye.